Algebra, one of the oldest forms of mathematics, right up there with basic counting and addition. Unfortunately, that means that nowadays it's something new is hard to come by, especially due to the fact that the last major discussion in the field was in 2023, which doesn't prove my point, but last formula was probably invented a while ago, right? Okay. Well, that's great. That's great to know. I mean, just because art's dead doesn't mean math has to be. Okay, so, probably all wondering, did I create an equation? As far as I know, I have not seen any other documentation of this, and I have searched everywhere, and nowhere else is this mentioned. And you might be wondering, well, what's this big equation? Okay, well, let me get to it. The equation is y is equal to y1 plus open parentheses the change in y times open parentheses x minus 1 close parentheses close parentheses. Now, as I said, I could not find any documentation of this, like anywhere. Now you might be wondering, what does that all mean? Well, if you shut up and let me tell you, then maybe I'll give you an answer. Now, I have no idea what this could practically be used for, so right now it's just kind of there. I mean, it's really cool, but the only thing that it could potentially be used for is finding data that you have lost, or just creating data. But might be wondering what kind of problem would even need this thing, because it just seems like an overcomplicated version of slope-intercept form. And you would be right if you weren't wrong. Okay, so here's the problem. So today I'm going to be explaining what this whole equation is about. Essentially what the whole video has been about up to this point, but if you haven't been paying attention, it's essentially, the point of this equation is when you have the change in y and the first y, but you only have one x. Hold on, wait. But you only have one x. So, I've explained how this works, but I haven't shown you how it works mathematically. First, I'm going to show you with my old problem. This table is obviously incomplete because it only has one x, but the flaw that I found with this is if you have the change in y be from these 2 points, change in y1 to y2, if your y1 is when x equals 1, then that means obviously that this x has to be 2. Now let me explain why that is. So if you were to set up this equation, so y is equal to 45 plus the change in y. So the change in y here is 50 minus 45, sorry, 50.6. Doing that gets you your change in y to be 5.6. So with 5.6 as our change in y, since we're changing from these two x's, or these two y, sorry, that makes the change in y here have to be 1, and I'll show you right here. And then x. So demonstration, if I put x as the x I want to go to, because this x is where you want to go. That's where the x that you want to go. So if you want to go to x2, then you put 2 there. Then -1. That just helps it work. I don't know why. Okay, so now if you go through this equation, you should get y when x is equal to 2. So if you go through that, that's y is 1, and then obviously 5.6 times 1 is 5.6. 5.6 plus 45 here. That gives you, well, these give you an extra 10, which gets you 50. Then the 0.6 just carries over. See, and that gets you 50.6. Now that's not really useful because this is just overcomplicated. This isn't really useful because this just overcomplicates slope intercept. And all you need is like 2 x's and 2 y's, and you already have that with this. Okay, so this one obviously works better because you see you have your first y right here. See, y when x is equal to 1, that's right here. Now this part doesn't really matter. If you want to read it right now and try to solve it with this equation, and then try not using this equation. But I'm pretty sure you need the equation for this one, because as you can see with the question marks, which are not how many x's are in between, there are more than just one x. Otherwise, that'd be kind of not smart of me. But it allows us to get the change in y without the change in y being connected to the first y. Okay, so our problem now, our formula is still the same, but our problem is different. So let's plug in our values. Y is equal to 12 plus the change in this number, which is 3, plus parentheses 3. Let me recap for myself because I had to go for a bit. So change in y is 3. And then next what we plug into our equation is the x variable in which we want to go to. Now the x variable doesn't really matter. I mean, honestly, we can just put 2x in order to get the next x in line, and that will allow us to get a slope intercept form. So I'm just going to put 2 minus 1. And that should get us the next x. Now the reason why this works so much better than this other problem is because this has them both right next to each other. I probably emphasize that a lot, but yeah. So this one more efficient because these two are separated. So our next y will be, so we just have the 3 because that cancels out. 3 plus 12, that's 15. Now you might be wondering, well, can't you just like add 3 to that to get the next y? And you can, and that kind of defeats the whole point of this. And you're no fun. But yeah, you can just add 3. That's the next x in line. But yeah, if you want to do this and like skip doing slope intercept form, that's what this allows for. This allows you to just get to the x if you don't have variables connected. Now, you don't you don't see this a lot in algebra because, I mean, it's kind of counterintuitive. But now with these new variables, we can figure out what the next x in line is. So let me bring down my calculator. If you ever use Desmos, if you haven't used Desmos, you probably should. So 1, 2, then we have 12, and we have 15. So from here, now we can make, whoops, done. Okay, now we do y1 okay. Now we have y is equal to 3x plus 9, and that gets us a slope-intercept form for this line. Do that. Now, to prove that we are correct, we need to find y when y is 36, and we need to find the corresponding x. So, and then boom. Now we know that this x is 9, and this one 10. So it all works out. Now you might be wondering, why is this useful if you can just add here? Well, this cuts out the middleman. You don't have to like add, put it in, do all that, put it into Desmos. You don't have to. You skip doing this, and you just. I mean, obviously, if it's a very low number, but you won't know that. This just skips going forward, and you just put it in, and it gives you the number that is the answer. You don't have to go through all this and search for it. No, let's cancel. Anyway, and I provided an answer key here. Well, let's see. And that's essentially the same chart, just filled all the way out. Although it skips 3. But yeah, look, y. Whoops. Anyway, I'll give it back to past me to continue the video. Oh wow, now wasn't that great? Now after that demonstration, you might be wondering how you can use this in your day-to-day life. Well, I have no idea still. I have already said that you clearly don't listen. But if you have an idea on how you could use this, or if you think this is useful, then comment below, because apparently engagement increases how much this video will be pushed. And if any of you guys have an idea that's worth talking about, then I will make a follow-up video. Anyway, a next video might be a while. Bye.